Good day, everyone. My name is Muhammad Al-Bakr, and today we are going to present our discrete structures group project called Library Borrowing System. In this project, we apply two discrete structures concepts, functions, and the inclusion-exclusion principle. Our scenario is based on a university library system that manages students, books, book categories, borrowing transactions, return records, and book availability. The main problem is that a library needs to keep accurate borrowing records. A student may borrow more than one book, and books can have different statuses such as present, checked out, or missing. If the system is not properly organized, it may be difficult to know which student borrowed which book, whether the book has been returned, or whether a book is missing from the shelf. Another problem is analyzing book category popularity. Some students borrow books from more than one category, such as programming, fiction, and thriller. If we simply add the number of students in each category, some students will be counted more than once. Therefore, we use discrete structures to model this situation clearly and accurately.
Hello, my name is Mohammad Zohaib. My student ID is 03914443. Now I'm going to represent the topic of our group project, system data overview and sample data. Our system includes four main sets. First set is set of students, which is represented by S. Second set is set of books, which is represented by B. Third set is set of book categories, which is represented by C, and the last set is set of borrowing transaction, which is represented by T. This system also follows several rules. Each student may borrow one book, but a student can also hold up to three active books at a time. Every book belongs to exactly one category. Every transaction records one student, one book, the borrowing date, and the status of the transaction, either returned or on loan. For example, John Lee borrowed three books, which shows why the system must support the multiple borrowing transaction for the same student. This is important because it affects how we define these functions in the system. You can see like there is book status distribution. Present books are 9 and checkout books are 9. Missing books 14. It represent like in our system how much books are missing, or how many books are borrowed by the students, and the present books in our library. Thank you. This is
Hello, my name is Sufyan Salim Bhura. My student ID is 0390415. My topic is function makes record unambiguous. So let's get started. The first discrete structure concept we applied is functions. A function maps every element from a domain to exactly one element in a codea. At first, we consider mapping students directly to the books using a function from S to B. However, this is not valid because one student may borrow more than one book. To solve this, we introduced and we used borrowing transaction as the domain. We define the borrower function as f maps t to s. This means every borrowing transaction maps to exactly one student. We also define the borrowed book function with G, where G maps to B. This means every transaction mapped to exactly one book. We also use the category function with C. So C maps B to C. This maps every book to exactly one category. Finally, we use status function. The return status function maps each transaction to either return or on loan, while the book status function maps each book to present, checkout, or missing. This function makes the system clear because every transaction has one student, one book, and one status. This helps avoid confusion in the borrowing records. Thank you.
Inclusion-exclusion principles. The second concept is the inclusion-exclusion principles. We use principle when some students are counting are counting in more than one group. In our library system, set P for programming, set F for function, and set H for filler. In our library system, there are 4 programming students, 5 fiction students, and 4 filler students. The students borrow both programming and fiction books, so we calculate for plus 5 means 2, which equals 7. The means 7 different students borrow programming or fiction books for all 3 categories. The total number of different students is 8. The principles help us avoid counting the same student twice.
Hello. So today we'll be talking about what we found in this, what the model revealed. So from our analysis, we found that functions are very useful for modeling a library borrowing system. They help us clearly identify which student borrowed which book, which category the book belongs to, and whether the transaction is returned or still unknown. We also found that the inclusion and exclusion principle is important when analyzing borrowing patterns across overlapping categories. Without it, the library may overestimate the number of unique borrowers. Another important finding is from the inventory status. Out of 32 books, 9 books are present and 9 books are checked out, and 14 books are missing. This shows that the library may need better inventory control because the missing rate is quite high. Next slide. As a group, the project helped us understand that discrete structures are not theoretical. They can be applied to real systems such as library management. We also improved our teamwork and communication because we had to divide tasks, discuss the mathematical model, check calculation, and prepare the report and presentation together. In conclusion, our library borrowing system shows how functions and the inclusion-exclusion principle can be used to create accurate borrowing records and meaningful category-based analysis. Thank you.